Let's work on question 7 now. So a student is considered to be in the top if his score is among the 2.5%. Now a score of at least 547 is needed to be considered a top student. Is that true or false? Let's see. First of all, let's understand visually what's happening here. We know that we're going to work with the z distribution because we're interested in percentages. But now we don't have the z values, we have the percentages given to us, and because we are in the top percent, right, the 2.5%, it means that we would be above average. So since the average of the population of 535 points is represented by a 0, right, by a 0 value on the z-score, it means that we are looking for the 2.5%, something like this tail over here, to find out this score. Basically, what z value do we need to be in the 2.5%? And that z value is going to give us the necessary score that we are looking for. So let's see how that works out. Now, remember this. The z distribution is symmetrical around the mean of 0, meaning that the 2.5% that we are having here, we have them over here as well. So we have this tail as well, 0.025. Now, since the z distribution, the z table, is giving us the proportions to the left of that number, we are looking in the table for the probability of 0.025 that's going to correspond to a certain z value. And if we have a look at these numbers, we'll find out that that z value is going to be minus 1.96. So the probability of having a z value less than or equal to minus 1.96 is equal to 0.025. And again, because it's symmetrical, that is the same as saying that the probability of having a value or z value of greater than or equal to 1.96 is going to be 0.025. So the same probability, it means we have the same z values, but one is going to be negative because it's lower than the mean, one is going to be positive because it's higher than the mean. Now, with that said, we can already move on and find out our actual score of the points, because this is the standardized score, but we want the normal score. So let's just write our z formula and we'll see how we solve it, because it's going to be just a simple math. X minus mu divided by sigma. We found out that the z value that we're interested in is 1.96, so we just substituted 1.96. X, we're looking for x. We want to know how many points does this mean, right? We still have this question mark. So x minus the mean, we know that the mean is given to us as 535, so x minus 535 divided by the standard deviation, and the standard deviation is given to us as 7, so that's divided by 7. How do we solve that? We do a cross multiplication, so let's do it in one shot. X is going to be equal to 1.96 times 7, 1.96 times 7, and then we add that number, so we'll have plus 535. We have 535. If we solve the math over here, let me just do it real fast. 1.96 times 5 plus 535 is equal to 548.7. 548.7, let's round up to 549. So it's 548.7, approximately 549. And the answer key tells what? It must have at least 547. No, it must have at least 549. So the answer to this question is false, and we are done.